Here we go with section 11.5. We're going to take a look at volume of solids, and we're going to briefly talk about the idea or the concept of density. We'll start off with volume. It is the number of cubic units inside a solid's interior. Remember, volume is measured in cubic units. So whatever it is, units squared, inches, centimeters, you name it, it is in cubic units. Uh, the concept of volume is how much can go, once again, inside. If I take a look at this container, a water bottle right here, it's how much can go inside of the solid, or this being a cylinder, let's say the closest thing to a cylinder, it's how much can go inside of here. Next up, we have Cavalieri's principle. It says if two solids have the same height and same cross-sectional area at every level, then they have the same volume. So an example, I guess a diagram right here is, let's say if we have a cylinder, okay, and the cylinder happens to have a radius of 5. And we have this next figure that has the same height, so if it's saying this also has a radius of 5 as well, then, and they have the same height, then the volume is the same, despite the fact that the second figure right here happens to be slanted. For our next term, we talk about density. It is the amount of matter that an object has in a given unit of volume. Now, density is different than weight. They get oftentimes confused. If I take two objects, for example, let's say um, water and gasoline. Okay, if I take a pound of water and I take a pound of gasoline, or if I get a pound of gasoline, they'll obviously be equal to 1 pound. However, the thing here is this: the amount of gasoline to equal 1 pound and the amount of gasoline to equal water is actually different because of the makeup of water and versus gasoline. It actually will take more gasoline to equal the same amount as water. Okay, so if you're to somehow, maybe one of these days, you get yourself a can and you fill it up with gas and you fill another one up with water and you try to weigh it, which I don't really recommend because it is pretty dangerous. Um, you'll notice that they are actually different. Another way to think about volume is this: if I were to fill this container up with water and weigh it, I empty the contents, or I have another bottle of water right here, or another bottle, and I fill it up with gasoline. The bottle, or when I fill this bottle up with water, it'll actually weigh more than filling this up with gas due to the nature of concept of density. When we come to similar solids, we will come back to that. Let's go down and take a look at our first core concept. We have right here, we will take a look at the volume of a prism. To find the volume of a prism, V is equal to uppercase B times H. Okay, volume is equal to the actual area of the base. Before, when we talked about, let's say, a rectangle, or let's say even a triangle, it's 1/2 base times height, but it's a lowercase b. So that is the base of the triangle. Right here, when we talk about the base, this is the base of the actual figure. Base of the solid. Now, it's capital B because the base of your solid could actually differ. in this diagram right here, it looks like it's a square. So then I would plug in, s squared. If it was a rectangular base, then I would plug in length times width. If the base was triangular, then I would plug in 1/2 base times height. So the base can vary, or the equation is very simple, right? But the hard part is remembering the different type of bases that you have or will encounter and being able to plug that into the equation. So the generic term is 1/2, or sorry, volume is equal to the base of the prism times the height. So when it comes to the cylinder right here, as we scroll down, you see that, hey, the equation to find volume of a cylinder is still the same. Volume is equal to base times height. However, this time, the base of a cylinder right here, you'll see is a circle. Because it is a circle, next to it, they plug in pi r squared, and then times the height of the cylinder. The last piece of information right here is the concept of similar solids. And it says two solids of the same type with equal ratios of corresponding linear measures, such as heights or radii, are called similar solids. The ratio of the corresponding linear measures of two similar solids is called scale factor. We've talked about scale factor when it comes to side lengths. And then, so if we think about what we have talked about in the past, we have scale factor, and I'll go ahead and we talk scale factor, and that was just based off of units. And so let me go ahead and if we're to base it off what we're looking at today, K being scale factor, right? We've used that term quite often. We go from scale factor to area. And for our area ratio, remember, that is going to be your scale factor squared. So what they're saying right here is that for us to go from scale factor to area, and now we can go to volume, that will be your scale factor cubed. And it should be pretty simple to remember if you recall that scale factor is in cubic units. All right, let's take a look at exercise number 1. Start off, find the volume of our prism right here. Now, what type of a prism is this? If you think it's a rectangular base, then you are incorrect. The correct way to look at these figures, especially when you want to determine what is the base, okay? Think about the base typically has two sides that are the same. Well, if you look right here, I'm circling it with the mouse, we have a triangle. And on the other side, we also have a triangle. When I could find two sides that have the same shape, then that right there will be the base. So this is actually, we could say, as a triangular prism. Okay. If we look at number 2 right here, look at top, we have the bottom. This right here happens to be a pentagonal prism. Once again, not a rectangular prism. That would be the sides around it. Okay, they typically, for a prism right here, they will have two sides that happen opposite of each other that are the same. All right, so we have right here a triangle. So simply put, we have ourselves area of a triangle, right? Because our base is a triangle. So we're going to go ahead and plug in 1/2 base times height. The base of the triangle is 3. the height of that triangle is 1.5. Now sometimes you get tricked because they have different units of measure right here. Be careful with that. All right. So make sure that the units are all the same. There's the base. This right here is the height. So we'll multiply it all by 5. Okay. The volume of this right here, go ahead and solve it out. We have ourselves 11.25, and it is centimeters cubed. Number 2, we have ourselves a pentagon, pentagonal base. So let's see here. This will be easy because they gave you the area of the base itself. So volume is equal to base times height. Remember, this one right here is a pentagon. You guys are lucky. These problems are a lot easier because sometimes before in the past, they didn't give you the area straight out. You may have had to find the apothem and then figure out the perimeter to find the area of that base. But the area of the base is pretty straightforward. They say it's 10, so we'll plug in 10 right there. The height is 4, and so the volume of this is 40, and then we have ourselves inches cubed. Let's go ahead and move along. So right here we have ourselves a cylinder, and remember, the equation stays the same. We still have ourselves volume is equal to base times height. However, remember, the volume of this is going to be different because the fact that it is a cylinder, and then the base is a circle. So volume equal capital B times H. The base right here in this problem is a circle. So we're going to have to plug in right here pi r squared. So volume equal, let's go ahead, we got pi. My radius is 2.5. We square that, that's the area of the circle. Then we'll multiply that by the height. And then the height of this cylinder is 7. And there you go right there. Make sure you plug things in correctly. I think they're having you round here to the nearest tenth. So volume we have is 137.4, and that is inches cubed. All right, so plugging that into your calculator, you could have paused it, plugged it in, make sure you get that same answer. Okay, don't forget it's important to work on your calculator skills. There's no excuses not to be able to get the problem right, especially with the calculator. All right, number 5, we'll skip number 4. Right here they say find the height of a cylinder with the base radius of 8 inches and a volume of 2010 cubic inches. So let's see what we have here. Always start off with the equation, always helps. Since we're talking about volume, we have volume is equal to the base of the solid times the height. It says the height of a cylinder with a base radius of 8. So from what I gather, what they're telling us is that the radius of this cylinder right here happens to be 8. So that right there is 8, and then they actually tell us what the volume is. We're trying to find the height. So we have ourselves a circle, so we have pi, and then the radius is 8 and squared. And then it says right here, the volume is actually equal to 2010. So we have pi, we have our radius squared, and then don't forget what we are actually trying to solve for right here is h. So simply put, we want to get h by itself now. You can go ahead and simplify this. We got 2010 is equal to 64 pi times h. And then lastly, We divide both sides by 64 pi to be able to get h by itself. So your height looks like it's approximately 9.9. And if we round that, rounds up to, we got ourselves 10 inches, and that is your height. Okay. Because right here, we are dealing with the height, not volume, therefore it is 10 inches. All right, next up, let's take a look at number 7. Okay, number 6 is pretty much the same, so we'll cut to the chase and go to number 7. It says find the missing dimension of the prism or cylinder. Right here, number 7, we have ourselves a prism. Okay, this right here, I would say, has what type of a base? Whether it's the top, bottom, or even on the up, front and back, all of the bases happen to be a rectangle. So we got volume is equal to big base times height. We have the base right here as a rectangle. So area of a rectangle, length times width. So let's go ahead, I'll put that right there, length times width, and we have to multiply that by the height. They actually give us a lot of information here, right? They tell us what the volume is, 661.5. The length and width, we can go ahead and use 18 and y. So what we know is that we got 18 times y right there. That's our base of the rectangle. And then that makes this 3.5 centimeters right here. That'll be our height. And then you just have to work on getting it by getting y by yourself. Okay. You can start off by multiplying 3.5 to both sides, or sorry, multiplying that with 18y. All right, so let's see here. If I take 18 times 3.5, that gets me 63. So this will equal 63. Y is equal to 661.5. And then to get y by itself, hopefully you already are ahead of me, and you know that you need to divide both sides by 63. So let's take 661.5 divided by 63, and that gets me 10.5. So that missing dimension right here is 10.5, and then we got ourselves centimeters. Because we're not talking about volume, we're not talking about area, it's actual missing side length. All right, and there you go. That is the end of 11.5.